Now we will discuss about functional group. Before we proceed about functional group, we need to understand what functional group actually is. Functional group are basically groups of ions, molecules or atoms which are responsible for specific properties of a compound. Suppose we have a compound X. Upon addition of a functional group to it, it will entirely change the characteristic of this compound. So, in this chapter, we'll be studying around 5 functional groups. The first functional group which we'll be studying is haloalkane. Halo means what? Halo means halogens. Halo represents halogen. Halogens includes bromine, chlorine, iodine and fluorine. But in your textbook, we will be studying only about bromine and chlorine. So now here haloalkanes, what do these haloalkane means is that halo means we'll be using halogen groups. In your textbook, we'll be using bromine and chlorine. Alkane means we will be adding up halogen with an alkane. We will see how this haloalkane naming works. We will be basically using chlorine and bromine. Now, this haloalkane which is written, it simply means how will this compound be named. Haloalkane. First the halogen will be named. Secondly the alkane will be named. Let us see how the naming will be done. Suppose when we were discussing about alkane, alkene and alkyne, I mentioned that if n is equal to 1, it will be met. N is equal to 2, it will be it, and n is equal to 3, it will be prop. So we will just, for example, take prop. That means we will take 3 carbons, and since we are doing for alkane, the name of the 3 carbons will be propane. Now here the functional group which we will be using is chlorine and bromine. Why is this dash? What does this dash represent? This dash represents that any compound to be added should be added to the left hand side. That means compounds will be added to the left hand side and this functional group will be present at the corner. So suppose we are taking propane 3 carbons. So as per this dash, it represents that this functional group should be present to the right hand side and the compound should be present to the left hand side. That means they will be situated at the corner. Let us do for chlorine. Now whenever we are writing down the formulas of the compound, we also have to maintain the tetravalency. Since here only one bond is there, that means how many more bonds to be added? 3 bonds. 2 bonds, so 2 more bonds will be added. 2 bonds, so 2 bonds will be added. Tetravalency will not be maintained here, it is only for the carbon. This very formula can also be written as, since we have 3 hydrogens here, it can be written as CH3, CH2, 2CH2, Cl. Why 3? Because we have 3 bonds. Why 2? Because we have 2 bonds. These 2 will not be counted. These are the bonds which are joining them. When we are counting tetravalency, then only we will consider this. But when we are writing, we will write down only the additional bonds. So here the bond comes here, and these two bonds also can be written as CH2. Now we have the functional group chlorine. But according to the name, how are we supposed to name them? Haloalkane. First, the halogen will be named. Secondly, the alkanes will be named. That means the number of carbon atoms present will be named. We have to name the halogens as halo. That means chlorine will be named as chloro. Bromine will be named as bromo. Our next word will be alkane. So when we are naming, since it is chlorine, we got our first name, which is chloro. What is our alkane here? Mit, it, prop. So we are doing for alkane, that means it is propane. 3 carbons present means it is propane. So we got here the name is chloropropane. Similarly, if we put bromine in place of chlorine, what will be the name? The name will be bromo. 3 carbons, that means propane. Why A and E? Because we are talking about single bonds, we are talking about alkane. That is why it will be bromopropane. Bromine will be converted to bromo while naming. Chlorine will be written as chloro. This is only for naming purpose. So halo we got this bromo, and alkane we got as propane. So this is how the first functional group will come into play. First functional group which we are using is chlorine and bromine. So upon placing the functional group to the alkane, we got the formula as CH3, CH2, CH2Br, and the name bromopropane. We can also use for 4 carbons, 5 carbons, 6 carbons in the similar way. If we are using for 6 carbon, it will be bromohexane. If we are using for 5 carbons, it will be bromopentane. If we are using for 4, it will be bromobutane. Depending upon the number of carbons, the name will keep on changing. Let us see the second functional group, which is alcohol. Second functional group, alcohol. Alcohol has a symbol OH. This dash also represents the same thing, that the functional group will be placed to the right hand side and the compounds should be placed on the left hand side. And whenever we are naming compounds for alcohol the suffix to be used is ol. That means after the alkane, what name we have to put? We have to put ol if oxygen functional group is present. Now let us see how the naming to be done. Suppose we are taking again for 3 carbons. 1, 2, 3. Now, as mentioned that this functional group should be placed at the last. This dash means that the alkane should be attached here. This should be placed at the last. So here OH. And we already talked about maintaining the tetravalency. That means the formula is these are all H. If nothing is written, just assume that these are all H. The formula is CH3, CH2, CH2OH. Now we know that 3 carbon means what will be the name? 3 carbons for alkane will be propane. What is the functional group present here? Alcohol. Alcohol has the suffix ol. We have to put ol. And remember that whenever 2 vowels are present, vowels means A, E, I, O, U. The vowels present with the alkane will be cancelled, because you see here alcohol symbol or the alcohol suffix is also starting with a vowel, which is O. So the vowel of the alkane will be omitted. So the name becomes Propanol, propanol. I hope it is clear that the alkane vowel, that is the last letter, if it is vowel, if it is A, E, I, O, U, it will be omitted and the functional group suffix will be added. So this is how for alcohol you have to put the suffix, you have to put the symbol, that is OH, and this dash represent that the alkane should be attached to the left hand side and this should be present at the corner. Next functional group which we will see is ketone. Ketone has the symbol and the suffix to be used with ketone is ONE. This is not one, it will be pronounced as on. Now you see that in case of ketone we have dashes on both the side. In case of haloalkanes and in case of alcohol, we saw that the dash was only on the left hand side. That means left hand side we have to attach the alkanes. But here we see that the dashes are present on both left hand side and right hand side. So what does it mean? So here it means that the alkane should be attached both from the left hand side as well as the right hand side. That means that this ketone functional group should be present in the middle. Let us do for propane again. 1, 2, 3. 3 carbons means propane. We also see that there is one more carbon present in the ketone functional group. So even this carbon will be counted in case of propane. Because if we don't count this carbon and if we place 3 carbons for propane and then again if we place one more carbon for this functional group, we will get 4 carbons. That means the name will change, it will become butane. So whenever we are doing for functional groups having carbon in it, that carbon will also be counted with the name. So here, since it is mentioned that from the left hand side and the right hand side also there should be some addition of the alkane. So what we will do is the ketone functional group will be placed in the middle. Now you see you have to maintain the tetravalency for these 2 carbons. This carbon already has 1 bond. So how many bonds does it need to become 4? It needs 3 more bonds. And this carbon also has 1 bond. So how many bonds does it need? It needs 3 more bonds to maintain tetravalency. So this one can be written as CH3 ketone group, then CH3. So since 3 carbons, it has the name propane plus the suffix of the functional group which is ONE. As mentioned that if the last letter is a vowel in the alkane group, this will be omitted because both vowels cannot be written together. So the one vowel of the alkane needs to be omitted. So the name will be PROPANONE, propanol. So this one I'm sure it is clear now for ketone. Now let us see the 4th functional group which is carboxylic acid. Carboxylic acid has a functional group COOH and it has the suffix which is oic acid. This functional group can also be written in this manner, OH. So here, same as the first 2, we see that the dash is present to the left hand side. That means addition will be done only to the left hand side and this functional group will be present at the corner. So let us do for Propane again, we can do for any number of carbons, but we are taking only one specific in order to avoid confusion. So as far as we have done for propane, we know that it will be CH3, CH2, and the functional group, which is carboxylic. How are we going to name this? Ketone, carboxylic acid, and aldehyde all has a carbon in it. So the carbon present in the functional group will also be counted for naming purpose. So how many carbons are there? 1, 2, 3. 3 carbons means it belongs to propane. Propane group. What is the suffix for the functional group? It is oic acid. Now you see this and this both are vowels. So this vowel of the alkane needs to be omitted. So what will be the name of the compound? Propanoic acid. PROPAN from the alkane, OIC from the functional group. So we get the name as propanoic acid. Now let us see the last functional group mentioned in your textbook, which is aldehyde. Aldehyde has the symbol, the functional group is, and the suffix present is al. This also can be written as CHO. You see that here also the dash is present on the left hand side. That means the compound will be added to the left hand side and the functional group should be present at the last. Let us take an example of propane again. CH3, CH2, we have seen that propane has a formula CH3, CH2, CH3. Here, why are we not taking CH3? I have already explained that. Since the functional group already has a carbon, we cannot add again one more carbon, because if we add one more carbon, the name of the compound will be changed completely. So, in case of aldehyde, ketone and carboxylic acid, we need to keep in mind that they already have a carbon, so we will not add additional carbon, but the carbon of this functional group will also be counted while naming. So this CH3, since we have 3 carbons, the name of the alkane will be propane plus, what is the suffix to be used for aldehyde? It is Al. Now this is also a vowel, this is also a vowel. So vowel of the alkane will be omitted and the name will be propanol. I'm sure it is quite clear about how the functional groups are and how the naming is to be done. Just remember that in case of aldehyde, ketone, carboxylic acid, they already have a functional group with carbon present in it. So while naming, the carbon will also be counted in the name. But for haloalkanes, since they do not have a carbon, the entire propane carbon will be counted. So in this session, we will just discuss about only functional groups in order to avoid confusion. And in case of any doubts, you can always approach me. In the next session, we'll be discussing about soaps and detergents.